So we've started here. I apologize. I clipped off the recording, so I'm going to do that again. So we've got a little more written than we need to, but this is Rges Algebra 1, and this is Lesson 28A, and we will be discussing our new concepts from Section 11.6. We will also be reviewing 11.5. Before we begin, I'd like to look at this passage. In returning and rest, you shall be saved. Now, this is the first part of Isaiah 30:15. This is a season of rest. Nobody can deny it as we're becoming more and more locked down, urged to stay in our house and social distancing. And what I want to exhort you in is that is just fine. That's fine. There's nothing wrong with having seasons of that. Of course, it is. There are stresses on society. I recognize that. Physical stresses, emotional stresses, financial stresses. And so in that way, it's very challenging. But for you as an individual, let me remind you, there's nothing wrong with having periods of quiet and rest. So don't chafe against it. Use this for the special kind of season that it is. Go ahead and use it to be more reflective in your heart, to take stock, to start a new hobby, to evaluate what you might want to be doing different, to pick up some new habits, to get in touch over internet or the phone, or writing a letter to people you don't normally make room for in your social life or schedule. You know, there's so many ways to FaceTime a friend and staying connected that way. We're just blessed. We're blessed that living under such restrictions, we have a technological society that allows us to do still so much of it, even from the quietude of our homes. So let me exhort you, in returning and rest, you shall be saved. So take advantage. Take advantage of this time. Allow it to produce something good, even in the midst of it. So pray that through. Think that through. What could be special, even, about this time? Okay. What could be an addition to your life during this time, rather than just thinking of the subtractions. So go ahead and consider that. Now, what I'm going to do right here is you have already, this is number 1, this is in 11.5. You have already corrected these with the answers in the back of the book. So if you have done a great job on that, and you have either got them all right the first time or went back and saw where you made your mistakes and could get them all to work out, then go ahead and just forward the tape till we get to the new ideas. But if you have not been able to do that, then I want to encourage you to go ahead and, I'm sorry, I'm looking at one that's difficult to read here. That's a 5. Okay, so, wait 1 second here. That bothers me. Okay, I apologize for my distraction. So go ahead and walk these problems through with me. I've picked up about 20 of them to make sure you're very well grounded in how to work these problems. And so this is number 1. The first one, you first identify, these are my two denominators. I identify my least common denominator, or my least common multiple, or the common denominator will be 45x. What will I need to multiply the first fraction by? A 9. And, of course, that's multiplying the numerator, 9 times 8, and 7 times 5. So I have converted the top fractions there to these fractions. Now I simply add them by adding the numerators. That gives me my first answer, and subtract them by subtracting the numerators. Notice the denominators do not change. So for the next one, I'll let you study that. The thing I'm introducing a little bit different is normally I would break this all the way down to its primes. But when I'm adding and subtracting, it actually becomes more efficient if I recognize what they share in common. And they share, in this case, a 6 and an x in common. So these are what they share in common. So if I keep that in mind, I need to multiply that by 2 to get the denominator of the first fraction, and by 3 to get the denominator of the second fraction. And then it becomes very quick, then just multiplying that out to get my denominator, my common denominator, it becomes very quick to identify what the numerators are going to be multiplied by. It's what they don't have in common. Multiply if this one is the 12x, I need to multiply it by the 3. And if the second fraction is the 18x down here, I want to multiply it by the 2. Okay, what these are still needing. Okay, there's the common, taking them all together. All right, so then multiplying only the numerator, I get 15 in the first one and 22 in the second one. Add the numerators together, you get 37 over 36x. Notice that denominator will not change. Subtracting, I get 15 minus 22, or a negative 7. Now, when we go to the problem number 5 here, what have I done different? Well, I've noticed that this is 12, and 4 goes into 12 3 times. So I leave the first fraction just as it is, and the second fraction, I will have to multiply the numerator by 3. I'm going to distribute it, becoming 3x plus 9. Ignore that negative sign right now. And the denominator is 12. Okay. So to add, ignore that negative sign right now. I'm not trying to refer to that yet. Let's take that away for now. Okay. So to add, I'm adding the x and the 3x, getting 4x plus 9, and with the same denominator. To subtract, that's why I wrote that in there. I'm getting, now be careful because that subtraction sign needs to be distributed, meaning on every term. So I get x minus 3x, that's negative 2x, x minus 9, that's negative 9. Okay, so be careful with your negative signs. Let me go on then with some more. Now notice, these are viewed, right? The addition and subtraction is viewed as a grouping. There's nothing common, so my new denominator will have to be x plus 3 times x minus 7, meaning that this will have to be the multiplier for this. So I'll have x minus 7 times x minus 6 for the first fraction. For my second fraction, I have my 2 binomials in the denominator. And notice my numerator, x minus 5, will, as a binomial, will have to be multiplied by the x plus 3. Now, another way you can kind of view that, which might be helpful to you, is I'm looking at these things have nothing in common, so I take that and multiply it by that. I take that and multiply it by that. This requires 2 FOILs in the numerator, and then gathering of any like terms. Well, there won't be any like terms until maybe I better go ahead and do this one. Okay, so my numerator here, let me keep plugging along. Now to add these, I'm going to get 2x squared minus 13x minus 2x would be minus 15x, plus 42 minus 15 would be, 7 and 3 minus positive 27. There we go. Okay, so that's to add it over the denominator. I'm going to be lazy. And to subtract it, notice you've got to distribute that negative sign. So x squared minus x squared is nothing. Minus 13x plus 2x is minus 11x. And plus 42 plus 15 as I distribute that. Okay, it would be plus 57 over the denominator. When we've got something like 17 and they have nothing in common in the denominator, again, just look at it this way. For my first one, it will be, the denominator will be multiplying these two together. For my first one, take the denominator of there and multiply it over. So we've got 2b, and for my next one, it'll be the denominator will be the 2 multiplied together. Take, for the second term, take the first denominator and multiply it. So this would be, I'm sorry, this should not be a comma because we are subtracting them. And this would be 3a. So I'm trying to get you to see these so that when they have nothing in common like that, you could really do them just almost visually. Many of you will be able to do them visually. So that will be your answer. Let's look at number 19, very similar. Okay, nothing in common, so my common denominator will be Rs. I'll take my second denominator, multiply it by the first one, minus. I'll take my first denominator, multiply it by the second numerator, minus 4s, simply, just like that. Okay, let me do a couple more of these quick ones for you. Okay, my common denominator will be 4a. The second one will be just fine. The first one will have to be multiplied by 2. This will be 6 plus 1 equals 7 over 4a. So the goal is that these would become more and more easy for you. Let's do number 27. You identify your common denominator, which would be between 3 and 4 would be 12x. I've already got the 4. 4 times what is 12? Or I can just look at this, okay, this part of it, because we already share the x. So the multiplier here would be 3. The multiplier here would be 4, just like that. So we get 15 minus 8, or 7 over 12x. Looking at this one, my common denominator will be 6. A multiplier here, but not here. We're not going to change the second one at all. So we have to distribute this because there's two terms. This becomes 2x minus 2 plus x plus 1. Gather like terms. This becomes 2x plus x, or 3x, minus 2 plus 1 is minus 1. Looking at 55, my common denominator will be x plus y over x minus y. So this becomes the multiplier over here, this becomes the multiplier over here, and you will distribute. I'm trying to illustrate this so you can kind of more and more work these in your head. So I'm distributing an x through this, and I get x squared minus xy. Minus, and I would suggest, so that's the numerator of the first fraction. I would suggest putting that negative sign right there before parentheses, so that you could distribute it carefully and not make your mistake with your negative signs, which is the most common mistake. So I'm going to take the x plus y and multiply it, distribute the y through it. That becomes xy, y times x is x times y, plus y squared. Now notice I did not try to do this step mentally. I'll do that in the next step. I would suggest that to almost all Algebra 1 students. Minus xy minus y squared. Gathering these middle terms, that would be over the denominator. Gathering my middle terms, I would have x squared minus 2xy minus y squared. Now, quite honestly, I'm not pleased with the answer he gives in the back for that one, because, of course, this could be factored to x minus y times x minus y. And therefore, I wonder why I didn't do that, but these two would cancel out, and this should be my final answer. Well, let's see here. What else might we look at? I think the rest, well, let me look real quick. Okay, notice with this one, the first term has no fraction. It's not a fraction, it has no denominator. So we will simply take this as our common denominator. The second numerator does not need to be changed, but the first numerator we need to create a first numerator by this. And so we will take that and multiply it through by the x. So we'll distribute that x. We'll get x squared minus 2x. My second denominator does not change. My second numerator does not change. X plus 2, see how that works? We're going to gather like terms. X squared minus 2x plus 1x is minus x plus 2 over x minus 2. And he actually did not factor that, but you could simplify that. So again, he seems to be not prioritizing that factoring right now. So 67 now, when you have something like this, x squared minus 3x plus 4 plus 4. Just going to give you a few hints rather than working it all the way through. We are going to recognize that this can be factored, so we factor that. Keep the denominator. No denominator here, so we'll use the same denominator as we did in the first term. Okay, and so we'll need to multiply that by the numerator. We'll need to distribute it, and you could go ahead and distribute that negative sign at the same time. So what we'll end up with in our numerator then, so then you go ahead and gather like terms, put it over the denominator. If you want to be a star student, make sure that you can't factor at all. But he doesn't seem to be concerned, or maybe even in this case, you cannot. You will not be able to factor. All right. So, and then finally in 69, be alert to 69. 70, you were not assigned, but the same kind of problem. Up until now, we've been adding and subtracting. Now, what are we doing? We're multiplying. So simple cancellation, the answer is x minus 3 over x minus 1. Okay, so new ideas, 11.6. He wants you to recognize a few simple ideas. Okay, first off, if we had x plus 6 over x plus 6, if we had the same thing, right, over the same thing, or I could have written it x plus 6 over 6 plus x. This is an ordering issue. Same thing, we still have a positive x and a positive 6. In either case, this would just equal 1. But if I had, instead, an x minus 5 over a 5 minus x, are these the same thing? We'll read my denominator with the x term first, and I get x minus 5 over negative x plus 5. That is not the same thing. But if I took that, notice what I've got is kind of the reverse signs. Okay, if I took then a negative out of this in the denominator, I would get x minus 5 over, if I took a negative 1, I would get negative 5 plus x. Now read them in the other order, the denominator with the x first. I would get x minus 5, x minus 5. So that's the same, except this negative in front. So this is the same as a negative 1. Okay, again, same thing over the same thing is 1. Same thing over the same thing, just in a different order, is 1. If all the numerator and denominator differ by are the signs, the answer is negative 1. What if I had something like x minus 3, x minus 3 over x plus 3? These are called the conjugates. There's nothing special about that. Those are just going to be, they're not related to one another any more than anything else. Okay? Now that's the first set of ideas, 3 special cases. The second set of ideas is simply understanding about a negative sign with fractions, which actually we have gone over quite a bit. So negative a over b is the same as, let me get that little mark out of the way so we can tell what we're doing, is putting it in the numerator is the same as putting it in the denominator. All three of those represent the same idea. You should know that by now from things we've covered before. But do be reminded, because you might need to use that. That becomes useful when we're doing examples. So let me show you the first example then. So using our new ideas, we've got x minus 4 and 4 minus x. These translate to a negative 1, right? The x plus 3 does not cancel with the x minus 3, but the x plus 2 cancels with the x plus 2, and my answer will be, I could put the negative in front, or I could distribute it. What do? They put it in front, x minus 3 over x plus 3, just like that. I could have written it in the numerator, like that. Either way. Let's look at number 2. Honestly, I do not like the way he demonstrated this problem. I think that it would be easier to do it this way. I will simplify this part because it's being subtracted from the other by canceling out the x's, and I would get 2/3. Here, in this, I would look at this as a group with my division sign, and I'll change the division to a multiply by the reciprocal. I would go ahead and cancel then my x's. 5 goes into 10 2 times, and I would multiply. 4 times 2 is 8/3. Doing my subtraction, 2 minus 8 is negative 6/3. Doing my simplification is negative 2. And I think that's much more straightforward. So let's look at the next one. Okay, recall that even though these look similar to one another, they're conjugates, so there's nothing special I can do. I'm just going to use this as my multiplier to that. So I'll have 2 times x minus 7 minus, I'm going to use this as my multiplier to that. 1 times x plus 7. Of course, I don't have to write that. I could have done that different without bothering to write that, just with the x plus 7. But this will help remembering to distribute that negative sign. Gathering my like terms, and of course my denominator here is going to be x plus 7 times x minus 7. Distributing, I'm going to get 2x minus 14 minus, distributing my negative sign, x minus 7, gathering like over my denominator. 2x minus x is x, minus 14 minus 7 is minus 21 over my denominator. There's nothing to simplify in that denominator. I'm just being lazy, but you would write it out. Okay. You could either put in x squared minus 49 or just leave it like that. There's no big deal one way or the other. Now let's look at the next one. Okay, walking through this last one because I see nothing special about the 5th example. I'm going to factor everything. I'm going to say this is x minus 9 times x minus 1. See how important factoring becomes. So you really have to master your factoring or take your, hate to say it, but take your Algebra 1 a second time. Not everybody can master factoring in one time through, but it is the critical skill. Okay, so you either have to study it or until you can learn it, or take it through a second time. My factoring down below here, I'll be the difference of 1, so I'll have a positive 3 and a negative 2. My numerator in the next one, I'll have x minus 2 times x plus 2. Those are the difference of squares. I'm sorry, it is the difference of squares, so it's the sum and the difference here. There we go. And this would be the same. I want it to think x squared minus 1, so I'm going to take that negative sign that will convert this to this, and put it right out front of everything. Okay. just a negative. It doesn't need the 1 there. Okay, but don't lose it. Make it nice and bold so you don't ignore it. And this then becomes x minus 1 times x plus 1. Now I get to go ahead and delete what I can as far as binomials. Looks like that might be it. So I end up with x minus 9 times x plus 2 over x plus 3 times x plus 1 with a negative in front. Okay. Now, if your answer that squares in the back of the book has it distributed out again with FOIL, then you'll have to. Otherwise, for me, this was a perfectly fine answer. And I see nothing special about the fifth example. Go ahead and follow it through, but we're not going to do that. Now, I would like you to do for homework. Okay, so this is all your homework. Make sure I don't always do this, and we'll go ahead and give the answers the next time, but make sure you do all your oral problems as well as 1 through 57 odd. And we'll see you on the next tape. And do make sure that if you are still confused about any concept, you want to keep up with your concepts, so make sure you text me. I'll put it here one more time. If you need review on a specific problem I have not covered already, and now don't give me any questions about problems I've already illustrated. Okay, make sure you're watching the tapes carefully. But if you need any questions on the general idea that you're still missing or on a specific problem, go ahead and text me and I will cover that on the next tape. You have a blessed evening.